So check it out. You guys have your periodic tables. I want to remind you guys that it's 50 points staring at you, so take care of these. Make sure they're pretty, make sure they're neat. If there's something missing, get it from your friend. If you don't understand something, get clarification. If you think I won't be able to read it, maybe you should erase it and write it nicer, okay? But we're going to be working on the last two things today, which is stoichiometry and limiting factors, okay? So the first one we're going to do is the difficult one. So we're going to do some stoichiometry, and what I need you guys to do with that is, let's see here. I'm going to grab a pen and we'll slide this over. So we're going to be working in the lower right corner on the back. Maybe. Where did? Let's zoom in. There we go. Now we go down. Hey. Super Panda. Hey, it's the moles. Hey, it's the avogadros. For deforestation. Alright guys, here we go. Okay. Alright, so let's talk about stoichiometry. You guys with me on this? Here we go. Stoichiometry is just a fancy pants word for dimensional analysis for chemical equations. Okay? And what we do is we have a given amount and we need to find amounts of other things that will either be yielded or created or however you want to say it. Okay? So first thing, it's super funny as a teacher when you see something that annoys you. Stoichiometry is misspelled, so I'm just going to take a little red right here. Okay, I'm going to drag it over a sec. And I'm going to make this S-T-O-I. Stoichiometry, okay? S-T-O-I-C-H-I-O-M-E-T-R-Y. Stoichiometry. Okay, now stoichiometry is the situation where we go from a known, and then we do the mole conversion, which this should be molar mass in grams. Then we do a ratio, which will be two numbers, okay? It can't be three, and we'll talk about that in a second. Then we go to a mole, and then we go to unknown. And many of you guys have no idea how this relates to this whole mess. Okay, so here we go. We start out with a known, so we're going to have one of these guys. Okay, and then we're going to move forward by doing one of these conversion factors to the actual molar mass. Then we move to the ratio from a chemical equation, and then we go to the other moles, and then we go here, and so we're going to do that. Okay, it'll make you guys a little feel better about this. Okay, so I'm going to go black on this one, and you guys will be given a chemical equation when this happens, okay? So you are now getting ready to do a test on stoichiometry, and the first thing you see is that there's a chemical equation there, all right? The chemical equation we'll be using today is H2O2 gives O2 plus H2O. All right, now, the first trick you'll always get on this, there's kids who are really good at stoichiometry, and they're really good at it, and the test comes up and they're like, sweet, I'm gonna fix my grade, and then they go to take the test and they don't balance the equation. Is this a balanced chemical equation? No, it's not, so we have to balance it first. So we have hydrogen peroxide gives oxygen and water. Notice how closely related hydrogen peroxide are to water. Okay, but they're totally different, right? Okay, drink a big glass of H2O2 and you'll vomit, okay? All right, so you guys gotta look at this. So here's the deal. Coefficients we put on the numbers, but subscripts nature does, correct? Okay, so looking at these subscripts, we have to figure out what's going on. And reminder, this is kind of like the equal sign, and so all this stuff has to be equal on either side, okay? So here we have two H's, and here we have two H's. That's awesome, okay? But on this side, we have two O's, and on this side, we have two O's and, oops, we have three O's. Now remember, we can't just like have a half of a molecule because that wouldn't be the molecule. So we have to increase the numbers on these increments. So what we're going to do is we are going to put a 2 over here because now we have 4 oxygen. And then so when we go over here, how are we going to get 4 oxygen? I don't know, we'll come back to that. How about this? We have 2 times 2 is 4 hydrogen. How many hydrogen do we have over here? 2. So I'm going to put my 2 right here. So now we have 4 hydrogens. Now let's go back to our oxygen problem. Over here we have 2 times 2 is 4 oxygen. Over here we have 2 times 1 is 2. And then we have 2 more over here, which is 4. So do we have 4 and 4? All right, now how many of you guys have to do this? I don't know why I have to do it, but I have to do it. If I balance a chemical equation, I have to put 1s in here. But why don't we put a 1 here?
Because it's known.
Because it's known or it's understood. It's understood. If I tell you there's a problem about X, you understand that it's 1x. Okay, correct? All right, cool. All right, guys, so this is what we got given. We got this guy. If you guys were to look in the upper left-hand corner of your back sheet of paper, you guys would see a bunch of equations there. What kind of equation is this? What type? Decomposition. You guys were taking something apart, so we're going to find something here. Okay? All right, cool. So now we have hydrogen peroxide, we have this. Now, what will happen next is they will give you a known. All right, so the known we're going to use on this one, I'll make this one blue. Okay, so the known we're going to do, and if you guys have to write this in pencil because your pencil is a fine tip and your colored pencils are all weird, that's fine. I'm just writing in a different color so you know what I'm working with here, okay? All right, so on this one, the given is, actually I'm going to write this in black anyways because it's going to be the same for all the problems we use today. Okay, so it's going to be 10 grams of H2O2, all right? This is what we know, all right? This is known. So I'm just going to circle with some red here. So we know this, okay? All right, now here's your question. So I'll do this in blue. Okay, your question is, how much H2O in grams? This is what the teacher asks you. Okay, you guys, we know that peroxide gives us oxygen and H2O. If I gave you 10 grams of peroxide, how much water would you have in grams? Now we have all the information we need to make a stoichiometric conversion or to do dimensional analysis for chemistry. Here goes. What is the known information that's going to go right here? What do you got? 10 grams of H2O2. It's very important that we start it out right. Okay, so 10 grams H2O2. Now it's important that we start it out right because we remember how you slash on dimensional analysis? You're going to slash on this too. So you can always see what your next step is. So this is grams H2O2. So we know that whatever we're doing is going to end up being grams H2O2. Okay? Now the other thing is, when we look at our stoichiometry guy up here, we know that the next thing we do is moles. So let's look at this thing. We have grams. Since we have known grams, the next thing we're going to do is 1 mole over the molar mass. This is the mole we know. We know him because he popped his head out. So he's up on top, right? Here's what I write. 1 mole H2O2. Okay? Now, to do this, where do we find the molar mass for H2O2?
Isn't it like that element?
It is. It's on the periodic table, and it's the atomic mass. It's the molar mass. Here we go, though. We don't want the molar mass for oxygen or hydrogen. We want the molar mass for 2 oxygen and 2 hydrogen. So we're going to need a calculator. Uh-oh, I can't quite see my screen up there. Let's try this one. Hey, it worked. Math tools, calculator. Okay, here we go, guys. If you guys look at your periodic table, I need to know what the atomic mass or the molar mass for oxygen is. 15.999. How many of those do we have? 2. So I'm going to go times 2. Okay, and then I'm going to hit equals, and that's what we got. Now, is there something else in this? What else? Hydrogen. So we have 2 hydrogen. So what I'm going to do to make this calculator work, because it was being silly later, is I'm going to add hydrogen twice. So we have hydrogen is 1 point what? 1.00. Let's go 8. Okay, plus. Okay, 1.008. Is it 7.9? Yeah, so I just made 8, whatever. Okay, we'll talk about how we round here in a second, because I'm going to go back to this and point it out, okay? All right, so ready? So now we have 34.01. We cool with that? Okay, so what that means is here, I'm going to write 34.01 grams. Okay, this came up last hour, so I might as well address it right now, which is super funny. When I told you guys that there was 10 grams H2O, I should have put a decimal point there at least. Okay, so what I'm going to do is say whatever we measured went to 10.0 grams. Okay, so I'm just going to make this 0.0. Sorry, it looks kind of funny. You guys might have to fix it on yours. Why would I do 10.0? What do you think came up later? What? Significant figures. If I told you guys 10 grams, all of our answers today would be one number. Because there's one significant fig. So it has to be 10.0. Okay? So we have 10.0 grams given. So what should this be? 10.0 again, okay? So we'll work with that all day. Okay? 10.0 allows us to know that when we get our answer finished, we're going to be using how many significant figs? 3. Okay, cool. All right, so now we went through and we knew our grams, and then we did this guy to get our molar mass, and we got our numbers. So we filled our number in, so we went from here to here now. Now we need to know our ratios. Where do we get our ratios from? Chemical equations. So now we have a ratio of 2 to 1 to 2, which is going to jack everything up. Okay? We don't use all 3. Did the question say anything about oxygen? No. So do we even care about oxygen? No. So what is the ratio of peroxide, hydrogen peroxide to water? 2 to 2. Now, how many of you guys already fixed that in your head to 1 to 1? If you write 1 to 1 on your paper, that's fine. But I'm going to write 2 to 2 on the paper because I want you guys to be able to look at this example and then see where you got the information. Okay? So what I'm going to write here is, well, I have to decide what to write. Stay with me on this, okay? We slash down and over, right? So what has to be right here? H2O2. So here's what we're going to do. I'm going to put down 2 moles of H2O2. Now, what's the other part of our ratio? So this one is going to be 2 moles of H2O. That's really important that you set that up correctly, because if we're going to keep slashing, we need the H2O to end up in the right place. Okay? Because just knowing what we're going to do next to slash, it's going to be something H2O, correct? Okay, so now we have our correct ratios. What do we do after ratios? We do moles again. Now this mole, do we know it? No, we don't know, because he's in a hole, right? So where does the mole we don't know live? Underneath. So now we're going to write 1 mole, and this one happens to be of H2O. Okay? Now, to get to moles here, it tells us we need 1 mole, but we need the molar mass above it. What do we need the molar mass of this time? H2O. So we need our calculator again. Maybe it's this one. Cool. All right, so more tools. Math? Did I lose it?
Up 2. Nope.
No.
On the main one.
Thank you. Calculator. Just kidding, compass. Okay, got it. Here we go. All right, you guys, so now we're going to clear this out. So what do we have in combination this time? Okay, 15.999 times 2, right? And then what are we adding?
No, not times 2.
Oh, it's not times 2, huh?
No, because that's
You're
what
right.
I'm talking
How about this one? 1.0, what did we decide it was?
008.
0.8 times 2
Yeah,
plus, then what's our oxygen?
15.99. 9. There you go.
Cool. So now our number is 18.015. Now, if you guys are just like trying to keep up, as we do this more later, I'm gonna have you do practice without writing it down. And if you have questions, ask a friend next to you, because some of you guys are writing these numbers down, but you have no idea where they're coming from. Okay, so this is 18.015 grams of what? H2O. Very good. Okay.
Different decimals for the 2.
I did.
You did 0.15 and then 0.1.
Oh, sorry. This is 18.15. Is that what it is?
Yeah.
So I just added. I put a 0 in there for no reason at all. That was it.
No, there's a 0. Like, why did you do 3 decimals at the end instead of just...
Oh, it won't matter because I just want to. Okay, when you're using stuff, technically we would use 3 for everything, but I want as many detail numbers as possible. So like when you're using the periodic table, if you use those numbers, you're putting in a calculator anyways. Use those numbers. Now, on here, I'm trying to stay to 3 because they don't fit in your periodic table example. Okay, but it's all about significant figs. So if we just stay with the sig figs, you'll be all right. But let's not get hung up on that one right now. Okay, so here's the deal. Now what do? Slash and math. Okay, so here we go with the slash and math. Okay, so when you slash, don't make it to where it's unreadable. Okay, I want you guys to be careful how you do this. So I have grams H2O2, and here I have grams H2O2. They're gone. Here I have moles H2O2, and here I have moles H2O2. Here I have moles H2O, and here I have moles H2O. And now I'm going to do something fancy. These 2's, when you have two 2's, what can you do? You cancel them out. Okay, there's no sense in multiplying the top by 2 and then dividing the bottom by, or dividing it by 2. It's just a waste. Now, what's the one thing left? Grams H2O. What was the question about? You guys set up your stoichiometric or your dimensional analysis correctly. Because what's left is grams, so I'll make this blue again. Make this grams H2O, which is exactly what we were looking for. So we're set now. Now all we have to do is math. Like I say, like all we have to do is math, right? All right, you guys ready to math this thing out? Okay, so what I'm going to do is I'm going to do the multiplication first, and I'm going to divide by what? 34.01. So I'm just going to roll across the top. So I have 1, 0.0 times 18.015 divided by 34.01. Is that all correct? Okay, and then all we have left is 5.29. So you guys, we're going to do 530, right? 5.30. Why? Sig figs. And 5.296. We have to round up to 6, right? Okay?
Wait.
All right.
So in that one, we'd only use 3 sig figs.
Yes, we're using 3 sig figs because the given number was 10.0, right? Grams, okay? Hey, do me a favor and pour on the floor on that bad boy so you don't pop that chair. I know you weigh like 65 pounds.
That's
Well,
all.
It's 55. And
There you go. I'm just a little jelly. All right, you guys ready to rock? Here we go. Watch this. Okay. I'm going to give you guys another one. You ready to rock?
No.
This one?
you go a little
No.
slower.
Yes, well, maybe.
What?
I do too. That's all right. I'm going to do this weird color and just roll with that. All right, so now your teacher asks you another question. They give you the same thing, and science loves to do this because it's faster for the teacher, it's faster for the tester. But I'm going to use the same scenario for a bunch of different questions. So last question was, how much H2O? My next question for you guys is, and I'm going to bring this down the page to help you out here. Next question is, how many molecules of H2O? Did I change the question? So are we going to do a slightly different procedure? Sorry, how many molecules of H2O? Okay. All right, so what we're going to do is we're going to use all the same information, but this should be really a lot easier, okay? So we're going to start out with the given. So I'm just going to move this calculator over here. We're going to start out with what's given, and it's grams, right? Is it exact same setup? Cool. So the thing we know is 0.0 grams H2O2, correct? Okay, now we have the mole we know, right? So he goes on top, and that mole is what? H2O2, okay? And then we do the atomic mass on these guys, which is exactly the same, right? Because we already did the math on this, right? So we got 34.01, and where do we get this information? Periodic table, okay, and so we got grams H2O2, okay? Then, do we have the same ratio this time?
Yeah.
What are we trying to find? Of H2O. So is it the same ratio? 2 to 2, so yep. So we're gonna do 2 moles and 2 moles, right? And the bottom one has to be H2O2 because we're gonna slash it with this guy later. And so that makes this one H2O, okay? Now we're going to the stuff we didn't know. So now we're looking for the mole we didn't know, which he goes in the bottom. So we're gonna have 1 mole. Let's see, H2O.
Yep.
Now we're not gonna do the same thing. Look up here at our diagram. I'm gonna slide this over. We made it all the way to here. We got to the mole we didn't know, and now we're trying to get to, is it grams?
No.
Nope. What are we going to? Particles. So we're doing molecules. And so what is it? It's an Avogadro. So here we go. 6.022 times 10 to the 23rd. And this is, what do we write? H2Os? Yep. Molecules. So molecules of H2O. Okay, ready? When we set these up, we have to think, what are we looking for? So what was the question? What did we end up with last? Cool. So that means that we just slash and math. Okay, so I'll make this guy smaller again. Let me see here. Okay, so we got grams, H2O2, grams, H2O2. We got moles, H2O2. We got moles, H2O2. We got moles, H2O. We got moles, H2O. Okay? And then we got the 2 and the 2, so I already slashed those. So what we're left with will tell us our answer, which will be in molecules of H2O, which is awesome. Now we just math it. Okay? So let's do multiplication first. Question?
Is molecules like molecules, right?
What's a molecule? Well, so like I'm not abbreviating it because how would most of you abbreviate molecules? MOL. And what are we working with up here? So we'll get there later, but for now I want your instructions, because this is your instructions for everything we do later. I want them to be very clear. Does that make sense? Okay? Even though it's kind of not clear because we have to write molecules super tiny. All right, so check it out. We're going to do the math across here. So we have 10 times 6 what? Okay. And then it's, let's see, then we divide it all by what? 34.01 equals. Okay, now we have 1.77 times 10 to the 23 molecules of H2O.
I'm confused on one thing.
What you're confused
Well,
on?
2 things. So first
Well, let's
off,
do one first.
So when you're getting the bottom, so for the top, first, second step, you have the 1 mole on top. How did you get the bottom?
So if we look at this little picture right here, this is your picture from the periodic table,
Yeah.
and this is your molar mass. That's why it's circled.
Yeah.
That's where we get the molar mass.
Yeah, but-
we're looking for H2O, right?
But you like multiplied it like 19.
So we had how many hydrogens did we have, and how many oxygens did we have?
Oh.
2 of each. Then we added.
So
it.
do we? Should we?
You can add all 4 numbers. The real reason I did that kind of weird is this calculator is being kind of sketched today, and so I just want to make sure it's working.
But on that one, like
Mhm.
the third one.
I'll tell you what.
One,
You won't have to copy these ones down. I'm going to do 2 more practice examples, and then you can just watch and figure it out as we go. Cool?
Yeah.
How many of you guys struggle because every time I do a practice example, you have to write it down while I'm talking? So now what I'm going to do is I'm going to do 2 more practice examples. You don't write any of them down. So we should be able to do them faster, and you guys should be able to keep up with me on this one, okay? So let's see here. Let's go to this page. Hey, it's blank. That's super helpful. All right, so once again, we're going to use the same kind of problem. But this time, we're going to solve for oxygen. Okay? All right, so here we go. We have, what's our equation? We got 2H2O2 gives 1O2 plus 2H2O. Okay? So now we know that. We know that we're given 0.0 grams of H2O2. Okay? That's the thing we know, right? There's my star. It's a really sad star. Sorry. Still sad. Okay, ready? Now the next one is our first question. And the question is, how much oxygen in grams? Now there's a fundamental problem here, right? Do we usually measure oxygen in grams? But I want to do it just so you guys know how to do this. Okay, we'll do the next thing in liters and it'll get all weird. Okay, or should we, you know what, we'll just do it now in liters. We'll make it weird right now. Here we go, ready? You guys are like, really?
Wait.
Here we go, starting. What do we know? So you know what, we're gonna just do this. There we go. Because we know it's a gas, right? So it's gonna be in liters. Let's just do that now. Do we have a chart that tells us how to do it? Then who cares? We know how to do it. So let's do it, ready? So we have 10 what? Grams. Very good. Now, the mole we know, right? It goes on top. Okay? All right, and then on the bottom here, this is not grams, it's actually liters, right? Oh no, this is grams. This is grams, right? So we need to go to grams down here. So we're looking for grams H2O2. Do we already do the math on that? So it's 34 point what? 0.1. Okay. Now this is moles of H2O2. Okay. Now we need this to match down here, so we're gonna go H2O2. Okay. And this is, now let's look at the ratio. This is 2, but the thing we're going for up here is O2. So it's actually 1 mole of this. Okay. I know you just said wait, so I'm going to go back to that. Ready? Look at your chemical equation. If we have 2 of H2O2s, when we get done, what do we have? 1 O2. This is our new ratio we're dealing with. Okay? All right, so I'll move this guy down.
Oh, that's a 1 O2. I thought that was a 10.
Nope, 1 O2. Okay? All right, so next, you guys, our ratio, we got that done. So now we need to go to the mole we don't know, right? And he's hidden, right? So he's on the bottom. So 1 mole O2. Okay? Now, look at your chart. What are we actually getting to? It's liters, right? So it's liters what? Liters of O2. Okay? So here we go. What has to go up here? What's the conversion factor? 22.4 what? Liters of O2, and it's a STP, but that's okay. That's just standard test, whatever. Okay. All right. So here we go. Ready? Now can we slash and math? Cool. So we got grams H2O, grams H2O. 1 mole here, 1 mole here. Let's see, 1 mole here, and 1 mole here, and that's what's left. That's awesome. It's gonna go over here. Now we can math. All right. So ready to math it? 10 times 22.4 is what? It's 224, right? So we have 224 divided by 34.01 divided by 2 equals, here we go. How many liters is it gonna make? 2.9, but what's, 3.29 liters O2. Cool? We're gonna do it one more time. And this time we're gonna go to molecules of O2. You guys cool with that? Or do you want to do atoms of oxygen? Okay, we'll do molecules of O2. We won't break your brains today yet. Okay, unless they're already broke. Anyways, so here we go, right? So this one, it is, but it's not. Do you have the same? We'll talk about it. Okay, because we wouldn't have the same mass because it's just 1, right? Instead of 2, which is a molecule, right? So let's just do this one, right? So this is how many O2 molecules. Okay, ready? Same exact setup, right? Here we go. Given 10.0 grams H2O2. Okay, we want to get to moles. 1 mole of H2O2. Okay, underneath that, that is 34.01 grams H2O2. All right. Then we go, our ratio is still 1 to 2. 1 mole of O2, and this is 2 moles of H2O2, right? And then we have to look at what we're doing next. The mole we don't know goes on the bottom, And since we're doing particles, what number do we use? Avogadro's number, 6.022 times 10 to the 23rd, right? Okay. And then when we do that, we should end up, after we slash in math, okay, if we slash in math, we're here, we're here, we're here, we're here, we're here, we're here, and that leaves this guy. So what is 10 times 6.022 times 10 to the 23rd? 6, 2. I'm sorry, clear. 60.22. Now we're going to divide that by 2. And then we're going to divide that by 34.01. And that equals 8. Now, do we write things in scientific notation that way? How do we write them? So we're going to write 8.85 times 10. Now wait up. If we made one bigger, what's the other one have to be made? Smaller. So ready? 8.85 times 10. If we make this bigger, then the other number has to get smaller. So it is 22. And these is what? Molecules of O2.
Okay, why don't you put 60.22?
Why did I do that? Because what's this times? I just multiplied it by 10 before we started.
Also, I'm confused on how you got the 10.2 GH2O2 out of the 2H2O.
The 10 points, you got this?
How you got that?
Because it was given.
Well, okay, no, that no. On like the questions, are they gonna give us that?
Yes, you guys, they will always give you a formula, but it's not a balanced equation. They'll give you an equation. Might not be balanced. And they'll always give you a set something. They might tell you how many molecules you have. They might tell you how many atoms you have. They might tell you how many liters of gas you have, or they might tell you how many grams.
No, I'm asking, will they give you the top part or the 10.0?
Yes, they will give you this and this. Like this whole deal here. Okay?
So I'm still confused on how you got the middle, like 1 mole and 2 mole.
That is, you had to figure out these ratios, and this is our ratios here. And if you're confused about where you put them, you have to be able to slash these guys. So the moles of H2O2 are here. That means the moles of H2O2 are here. Okay? All right, now let's not hurt your brains. What do you got for a question?
For all of the oxygen, why don't you take the oxygen, like the 2 oxygen out of the H2O?
So you just want oxygen by itself?
Yeah.
So the trick here is they asked for molecules, so they wanted this. That's what they were looking for. If it asks you how many atoms
That's when
of oxygen, you would have to do particles, so we would still use that Avogadro's number, but would we use 34, or sorry, would we use, when we go to that, it's gonna change it up a little bit. Okay, all right? So now let's just not hurt your brains anymore, and let's do something silly, because I'm better at silly. All right, cool, we can get rid of that guy. All right, so now, I have to draw this over here because I didn't leave any space for it. You guys have a nice, good chunk of space between your trees and your chemical equations for photosynthesis.
What if you drew force?
We have this here. What?
So here's the deal. So let's see. You might want to work in like space, or you can work down here. Okay, right here. Okay. All right. Most of you guys will probably put it in there. Yeah. I'll show you guys what we're drawing. It's the last thing we have to draw on here. Okay. And we're gonna draw it like this. Let's see. Okay. So we're gonna make a couple of boxes. This first box is gonna be about 2 centimeters tall, and it's gonna be like 6 centimeters long. The next box is that we're going to draw. We're going to skip a little like 2 centimeter space, and we're going to draw a 3x2 box and another 3x2 box. Okay. All right.
Did you say 6 centimeters?
Yes. So I'll just throw this out there. This is 3. This is 6. This is 2 and 6. This is 2 and 3. 2 and 3. Okay.
Have to be extremely.
No, it doesn't have to be extremely. I'll just show you guys what's up, and you'll be all right. Yes.
Where is that? Where's the infinite?
So what did I tell you guys about where to put it? Wherever you can make it fit. So you might want to watch me draw it, but this is as big as it gets. I'm going to put some information around it, but this is the drawing. Okay, and what you're drawing is, this is, let's make this red because this is, oh, I guess we won't make it red. This is Lil Doggies Hot Dogs Unlimited. Okay, and I'm just gonna draw a little doggy here. Let's see. Let's see. So this is little doggies hot dogs unlimited. Okay, and so what we got here is and that's little doggy. Oh. So Lil Doggy was super excited to start his own business. He's like, hey, I'm a wiener dog, so I can sell hot dogs. That'll be catchy. And so he ordered his hot dog buns, and his hot dog buns.
Oh my gosh.
Okay, hot dog buns. They come in a package that says ×8. Okay, and then he ordered his hot dogs. The actual meat. His hot dogs come in a 10 count. Okay, he didn't have any other money, so he made the stand out of the wrapping that it came in and the 2 boxes. Great. He wants to sell hot dogs. Fun story, hot dogs come in packs of 10 and buns come in packs of 8. How many hot dogs, complete, can you actually sell? You want to sell 8 hot dogs, right? So when you get done with this, what we're actually talking about chemically is we're talking about a concept called limiting factors, okay? Okay, so hot dog guy here, he spent all his money. So day one, he's gonna have what left over? If we balanced this, he would have how many actual hot dogs? 8, and then how many leftover wieners or hot dogs or whatever, okay? 2. All right, now, that's not good for business. So he should probably balance this equation out. A really easy way to do this would be to buy 10 boxes, or 10 things of buns, and 8 things of hot dogs, right? How many total would he have? 80 of each. And so how many hot dogs can he sell? Awesome, but is that the lowest combination? Because he doesn't have a lot of money. What's the lowest combination?
5 things of buns and then about 4 things of hot dogs.
Okay. You guys, when we talk about this and we decide to go 5 buns, and this is boxes, okay? 5 boxes of buns, and we decided to go, how many did we decide? 4 boxes of hot dogs. You guys, we balanced our equation, okay? But what we identified is, what is the limiting factor if we don't pre-think this? Yeah, it says unlimited, but you know what's funny is we probably should change that, huh? Because he found out right on the first day, is there a limit to the hot dogs he could sell? You guys, the limiting factors is the smallest amount of something you have. I'm going to give you another real world situation, okay? And I'm going to talk really fast, but you just have to listen to it, okay? McDonald's hamburgers are simplistic, but they sell a ton of them. Ready? 1 bun, 1 burger, 2 hot dogs. Or sorry, 2 hot dogs. Let's start over. 1 bun, 1 burger, 2 pickles, 1 squirt of ketchup, 1 squirt of mustard, and 1 sprinkle of onions. The ratio there is 1, 1, 2, 1, 1, 1. If I was to order 10 of each of those things, if I was to buy 10 of each of those things, what's the limiting factor? Which one do I need 2 of? The pickles. I could only make 5 hamburgers, so I would need to order twice as many pickles so that I could sell these things on a consistent basis, regular basis. You guys, limiting factors in chemistry, if I went way over here, and I know some of you guys are taking notes, but I'm going to slide over here. If I ran a company that sold water and I had a ton of hydrogen peroxide around, that'd be super cool. Because every whatever of hydrogen peroxide I use, how many H2Os am I going to get? The same amount, it's equal. But if I was running an oxygen company and all I had was hydrogen peroxide, you're gonna have how much oxygen when you're done? Half of whatever you started with. Okay? So the really interesting thing about this is people would say, well, that's cool. That means I can just balance a chemical equation to tell you the limiting factors. But they're not going to ask you a question about the ratio. They're going to tell you, you have 10 grams of this. How much of this do you need? They're going to say, so you guys, the trick here is you need to understand limiting factors is just identifying what is the element or the piece of the whatever that's going to limit how many others can be completed. Okay? Then you have to do a stoichiometric conversion to tell me the actual real numbers of what's needed. Are your heads all exploding? Here's what you have next. You have a very easy task. You need to take that Moodle assignment quiz, whatever you want to call it, until you get a 10 out of 10. And the one I'm talking about is 12/5 atomic regions and groups or something like that. Okay? And you guys need to probably get that done by tomorrow because I'll have another quiz for you guys tomorrow. Cool? Wait. I'm going to answer your question after I hit stop on this.